During nuclear fusion, two nuclei fuse while releasing energy. The fusion of deuterium and tritium nuclei is best suited to produce fusion energy. Deuterium consists of a proton and a neutron, while tritium contains a proton and two neutrons. During the reaction, deuterium and tritium nuclei collide, producing one helium nucleus and one neutron, and releasing energy. As the positively charged protons from the nuclei repel each other, high activation energy is necessary for the atoms to achieve sufficient proximity to each other and start fusing. When the reaction takes place, more energy is released than invested. The reaction is exothermic. When nuclear fusion takes place in stars, the activation energy is provided by the enormous pressure and energy of gravity. The devastating force of the hydrogen bomb is also caused by nuclear fusion. The energy necessary for the fusion in a hydrogen bomb is provided by the explosion of a nuclear bomb. A peaceful use of fusion energy has not yet been developed. Several reactors have been built, but their operation is not economical. It requires more energy than it releases. However, the technology offers great promise. Deuterium and tritium are available in basically unlimited amounts. The operation is environmentally friendly, as the end product is helium. There is no radioactive radiation, and a huge amount of energy can be obtained from a small amount of fuel. A large international project currently underway will probably result in a breakthrough in developing nuclear fusion. The construction of the International Thermonuclear Experimental Reactor, or ITER, began in 2006 in southern France. The reaction itself takes place in deuterium-tritium plasma, that is, ionized gas consisting of electrons released by the atoms and of deuterium and tritium nuclei. The activation energy is provided by heating the plasma to a temperature of about 100 million degrees centigrade. At this temperature, the wall of the reactor would melt. Therefore, the plasma is kept in motion in a ring-shaped magnetic field. The magnetic field is produced by a toroidal electromagnet. This type of fusion reactor is called a tokamak reactor. The plasma in the tokamak is heated by electricity and microwaves. The fusion reaction starts at an extremely high temperature. The construction of the ITER reactor is expected to be completed by 2018. It has been designed to produce 500 megawatts of output power for 50 megawatts of input power for up to 400 seconds. The ITER has been designed for developing and testing the necessary technologies for energy production, not for industrial energy production itself. Another reactor, the 2000 megawatt demo, has been proposed for continuous energy production. The 7 participants in the ITER project are the EU, the US, Japan, South Korea, India, China, and Russia. The full cost of the project is about 16 billion euros, half of which is paid by the EU. This international collaboration will hopefully result in an environmentally friendly and safe technology for continuously satisfying increasing energy demands.